So how is everybody doing? Yeah? Having a good conference so far? Cool. Very cool. You know what? This is a big crowd. Let me take a selfie. Do you mind? No? Yeah. Cool. That's great, guys. Let's try to trend this on Twitter. I'll post it later. Cool. So let's get started. How many of you have heard of Node-Chakracore? Well, okay. Well, I'm glad I'm here. By the end of the talk, maybe more of you will know about it. So let's get started. So my name is Arunesh Chandra. I'm a program manager at Microsoft, working on specifically Node-related stuff. And Node-Chakracore is one of the main projects I'm working with, and time travel debugging, which I'm going to talk about later. But I'm here representing a really passionate team of people at Microsoft working at Node. And we all are very active in the community, and we truly want to advance the state of the art for Node.js through our contribution. So feel free to reach out to me through these social handles. We'll love to hear from you. So today I'm going to cover a few things, like what is Node-Chakracore, what was the motivation behind it, and how we are involved in the community and trying to grow the Node ecosystem, and also kind of bring fresh ideas to the table. I'll be also showing some videos, some demos rather, not videos, and also point you ways to get involved with this project if you want to. All right, so one thing for sure, we all can agree today is that we all love Node.js, right? And another thing we love is NPM. And NPM has fueled the growth of Node.js and taken JavaScript to a new height. So NPM has seen an explosive growth in the Node modules being published and used on a daily basis. By this, making NPM the largest open source module repository on the planet. And Node.js was built on top of Google's V8 runtime, which is a very capable and modern JavaScript engine that has helped Node to be where it is today. It's very cool. So from the surface, it might seem Node.js is everywhere. It runs on a variety of hardware like x84, x86, ARM, and many more. But if we take a closer look, we find that there are gaps in this story. For example, it is not on ARM Thumb2 instruction set. It is a newer instruction set of ARM, and it is not supported on that device because V8 is not available on that device. And this gap actually prevented Node developers to be able to target devices running on ARM Thumb2. So the story actually begins here. Microsoft came out with a new OS focused around IoT devices, which supported this newer ARM Thumb2 instruction set. But Node, as it was, would not run on it. And we all know that Node developers are always on the cutting edge, and the IoT is one of the areas of their interest. So we absolutely wanted to provide a Node.js experience on this platform from the start. So this presented an opportunity to grow the Node ecosystem to support devices it did not support before. And hence, Node-Chakracore was born. It was born to fill this gap for developers to target a new platform and to grow the overall Node ecosystem. So you might ask, what is Chakracore? Let me take a moment to explain you quickly, tell you a little bit about Chakracore. So Chakracore is the core and open source part of the JavaScript engine that powers the Edge browser on Windows 10. So it has, the purple part here on the chart is actually the core and Chakracore piece. It has some hosting APIs called JSRT hosting APIs. You can use these APIs to host this engine in your own app and process JavaScript if you want. And Node is a host. It hosts a JavaScript engine. So right. It has some diagnostic APIs where we expose some of our innovations that we'll be talking about later. Chakracore also has a interesting feature that could be very useful for Node. Is that you can actually turn off the JIT compiler inside this engine. And why is it beneficial? Because it can let you run this engine on constrained devices. Devices can be constrained due to various reasons. Due to available memory or CPU for that device, or due to policy restrictions like Apple iOS. iOS actually, the Apple Store has a policy that they will not allow JITting to be executed on the device from an app that is downloaded from the App Store. So Chakracore is actually kind of fits the bill for those kind of constrained scenarios. So you see also some gray boxes there. The gray boxes are actually Windows-specific pieces, like the bindings to the browser, bindings to the Universal Windows Platform, and the COM APIs for Windows. So when you mix that up with the core, it makes the full Chakra engine. So the JavaScript piece is the core part, and the external bindings for Windows-specific use case makes up for the Chakra engine that is part of Windows 10. Last year, we ported the Chakracore GC, the garbage collector, and the JIT compiler to Ubuntu and Mac OS to bring the innovations coming out of Chakracore to other platforms. So in short, Chakracore is a standalone, cross-platform JavaScript engine on its own right. So coming back to Node-Chakracore, remember the motivation here was to support Windows 10 IoT running on ARM Thumb 2. And since Chakra was already part of the Windows OS, it became obvious choice to power Node with this new JavaScript engine that was optimized to run on ARM Thumb 2. So we created a shim on a node that translated the V8 API calls to be serviced by Chakracore using the same JSRT hosting APIs I talked about. The idea to have this shim was that your application code running on top of Node continues to run without any modification. And you could change the Node binary underneath it with no problem. So hence, with this, we kind of grew the overall Node ecosystem by enabling the developers to be able to target a new hardware platform. So Node-Chakracore is now being maintained as a separate repo on GitHub under the Node Foundation. And there are official builds, nightly, and the stable builds that are coming out. So you should check them out and try it. So I often get asked, what is the point of Node-Chakracore and why we are here? I thought I should take a moment to explain why we are here. These are some principles that state our purpose and guide the Node-Chakracore project. So we're here to help grow the Node ecosystem. We are here to collaborate with the community to solve tough technical problems. We are here to innovate and advance the state of the art for Node. And while we are doing this, we want to be open and transparent to the community. So I'll give you an example. I'll give examples for these principles that we're working on. So for growing the Node ecosystem, I discussed before, we brought Windows IoT, a new device target to Node. Another example of enabling growth for Node.js is a project called Node.js for mobile apps. It's created by a company called a company in Barcelona, I believe, called Genea Systems. And this project is using Node-Chakracore to bring Node on iOS. So that has never been done before. And Node-Chakracore is enabling this brand new feature. And the reason why, the reason I talked about earlier, that Chakracore can be built without using the JIT compiler, and that satisfies the Apple's App Store restriction. And that's the reason why this project is using Node-Chakracore to power iOS scenarios. So this project was started to address a new trend that we are seeing in the community, where mobile apps that are getting built with expectation of unreliable connectivity, or just peer-to-peer connectivity in some cases. And these scenarios include apps popular in countries where it is expensive or unreliable. They have expensive or unreliable broadband infrastructure, or disaster zones, or large factory floors, remote oil rigs, where connectivity is a problem. That's where you are seeing that apps are getting built which are not always connected. There's an initiative started a few years ago called Offline First, where the mobile apps are built with local cache and a store and forward technique to mitigate the connectivity problems that they're trying to solve. If you were here yesterday, you may recall an awesome talk by Carissa about decentralizing data access through peer-to-peer communication. I was talking to her later, and she also uses offline first concept in some of her projects. So it is quite a popular thing. And in this new model, using Node is being seen as a useful framework for the backend part, where your logic resides of handling merge conflicts or store and forward techniques. So we're delighted to be enabling this new trend of mobile apps with Node-Chakracore on iOS. And there's this URL you should check out. There are some demos about this project, and also some more information if you want to know more. So community collaboration. So solving tough technical problems facing the Node.js community is another important area of focus of ours. And Node.js is known for its vast ecosystem of NPM modules. And some of these modules are actually native modules that are directly bound to V8 APIs. And these modules suffer from breakage on every new release of Node.js. So by some estimates, 30% of overall module ecosystem gets impacted by this problem. So sometime earlier, Dan Shaw, who's a well-respected Node expert in the community, tweeted that Node customers are not upgrading their Node versions in production deployment because of this module compatibility problem in the ecosystem. And this problem also adds to the cost of maintaining these modules for every Node release that comes along. So module maintainers have to pay additional cost to keep update with a Node version. So this clearly is a tough problem to solve. And in order to solve this problem, Node has to provide a binary level interface stability, also called ABI stability. And we cannot afford a large ecosystem like Node to keep breaking this module ecosystem on every release. So an ABI stable node will help solve two problems I mentioned before. It helps reduce the friction in having people upgrade Node versions in production deployment, and sometimes it's critical. Sometimes they have security patches to apply, and they are kind of hesitant to do that because they fear of the breakage. The other problem it will help is it will reduce the cost of maintenance of these native modules by the module maintainers. So to solve this ABI stability problem, the community got together from individual contributors to Node Foundation member companies like IBM, Intel, Microsoft, Google, and others to charter a new project called NAPI. So NAPI is a stable Node API layer for native modules that provides ABI compatibility guarantees across different versions of Node, and also across different flavors of Node, like Node-Chakracore. So instead of having your native modules directly bound to V8 APIs and updated on and required to be updated on every version of Node, module authors are being recommended to take dependency on NAPI instead, and that will not require them to update their modules on every Node release. It will just work. So this feature is available on Node 8 as experimental, and Node 8 and onwards. And there are conversations happening in the community about porting this feature to older versions of Node, so that the modules can work across different Node versions, even older ones. So let me actually show you a demo. I wrote a simple app that uses a native module called Level Down, and this app. Let me see if I can. Okay, yeah. So this app actually, what it does is it reads and writes from a level DB database using a native module called Level Down. And typically what happens is if you have an app dependent on a native module, and if you change the Node version underneath it, you need to do a recompile of the native module. But here, I'll show you what the experience is with an NAPI module, okay? So let me show you first the package.json that is using. So package.json, this resolution is actually kind of. So here, this package.json is using a fork of Level Down, which is NAPI enabled. All right, and typically, when you're using a native module, the module gets compiled on install time, and it creates a file called .node. Let's say dir level. So I've compiled this. So there's a .node file. There's only one. So typically, what happens is there's one file per version. But here, I have done the setup. This module has been created using NAPI, and I'm going to just run the app here. So let me choose a version of. So I'm using a tool called NVS. I don't know if you know. It's called Node Version Switcher. And if you're working with multiple versions of Node, this is a really handy tool to let you select which version of Node you want. So I'm going to use Node version 8.x here, and just run the app. All right, and I will get the browser here. All right. So this is where it is running. It's a Node app demo running on Node version 6. This is the current time. Okay. So what it does is it reads and writes to a level down database. So let's go ahead and write DB entries here. What's going on? Oops. Okay, here. Sorry, demo app. Okay, so so here you can see that you can add an entry to the database like this, and it shows you that it was added at this time. This is Seattle time, so don't get confused. And so this app used a native module, created an entry to the database, and here we're gonna kill this app and show that this got killed. So this is no longer working. And now I'm going to go show you that now if we change the version of Node underneath it, I'm going to use the other version, and you can use another version of Node, but I'm going to show you for time just using a different flavor with Node-Chakracore. Okay, and then I run this app again. And you refresh this. What's going on? Oh, not even. Hold on. Sorry about that. Okay. Let's reload this. So now it shows that it's running the Node-Chakracore version. Okay? And you see that Node-Chakracore version read the old entries from the database using the same module that we built before, and you can write to the same database using a new Node version totally. So for native module authors, this is a pretty big deal. I mean, this kind of provides an experience where you can change the Node version underneath it, and it doesn't. You don't have to break the app for that. Okay. So let's move on to the next principle that we like to state is innovate to advance the state of the art. And we're really passionate about debugging innovations in this community, to bring debugging innovations. So a recent survey from Rising Stack actually showed that debugging is the #1 problem that faces this community. Node developers are frustrated with debugging issues in production. And we want to make debugging great again, because I'm a C++ developer, and debugging in other languages are the tools are pretty sophisticated. But in Node.js, when we talk to developers, they are still using console.log to kind of figure out what's going on. So the tooling is not very sophisticated today. So there's a concept that we call time travel debugging, and it's something C and C++ developers are kind of very familiar with. It's an ability to step back in time in their code and inspect the control flow of the execution of how a faulty code got executed. So we are trying to bring this capability to Node. And this feature works with a record and replay scenario, where if you have a faulty execution path, you run through a tracing, and then the trace that gets generated, you can load it up offline in your debugger and inspect the code by going back and forth. So I can actually show you another demo if this works out pretty good. Let me. All right, so here, this is another app where it is showing there are a list of users, and it is showing what kind of data they're working on, and there's obviously a fault in this, and we're going to generate the trace and do a replay of that and see if we can find the problem. So what I do is I run this app. We know that it's faulty with a flag called record index.js. Okay, so first, this is a Node-Chakracore demo. So here I'm going to select another version of Node-Chakracore where this works. And I'm going to do a node-record index.js. So it says recording is enabled and the app is running. So let's see if I can get this going. Yeah. Okay. So here you see there are some users, Beatrice, Betty, Smith, Bob, and if you click on them, you can see their files they're working on, and things look good. But if you go to Susie, this app doesn't work. It fails. And it says directory not found. And typically when you see an error message like that, you'll say, all right, let me just take a look at that and see if the directory exists or not. So I go here, I kill this, and I see where is the directory exist? Well, it does. So what happened? So what I do is I open up code, Visual Studio Code, my favorite editor, and what you find here that there is a plugin that we wrote about this, and the plugin actually knows where to find the trace file, and it brought the trace file here right into VS Code and says, okay, it is available for you to take a look at it. And how you do it, you just say load for debugging. And what it does is it loads this trace file in your debugger, in your favorite debugger affordances are there, and you can put breakpoints, you can see local, call stack, you can see everything you want over here. So now what I do is, so this is the call stack. You can see how the code got here. So if I go to this function here, this resolution is killing me. But you can see that this function was trying to use a test data Susie, but instead it used the user data Susie test data. And you can actually set up a breakpoint in the past and do a reverse on that. You can go back to that location, and you can see, okay, there are the users, the user data Susie is where the data is supposed to be looked at, and here you're using the app is using something different path. So it was a bad path scenario. So if you look at test data, and here you can see the name of the folder should have been Susie and not data, and so that's how you can step back in time using the trace with an affordances like VS Code debugger to be able to inspect the problem that you're having. So that's time travel debugging. And this is available as a beta offering right now. You should try it out. It works on VS Code today. So a quick story recap. Node-Chakracore is trying to grow the Node ecosystem with bringing Windows IoT as a new device target for developers, and also helping Node.js on iOS story. We are working with the community to solve tough problems like advancing the ABI Stable Node project with NAPI. We are innovating to push the state of the art for debugging with time travel debugging, which is available in beta today. So Node-Chakracore is in pre-release status today, but still Microsoft Edge Developer Portal is powered 100% on Node-Chakracore. It's a large global website that is spread across multiple data centers and processes over 16 million requests per month. And this is running their 100% traffic on Node-Chakracore. So this kind of shows that even though it's a pre-release status, it is highly reliable for people to play around. We are also delighted to find that Travix, an online travel agency that is using Node-Chakracore for its time travel debugging capability that I showed you. And they do it, they've built a homegrown CI/CD pipeline where they actually allow, they run their code into time travel debugging mechanism. And when they run into a problem, they already collect the traces, and the developers don't have to go and investigate the problem and repro the problem and things like that. And they are able to easily cut down the cost on their deployment testing. All right, so with that, you should. I invite you to kind of try these out. TDD is something is interesting for a lot of people. You should try that. Node-Chakracore official releases are available on this link, and if you are interested in NAPI, get involved with that as well. That will be super great. All right, with that, muchas gracias.